All right, so we are going to move forward to lesson 7.4, where we're going to talk about special types of parallelograms, focusing on rhombuses, rectangles, and squares. So let me present my screen. Okay, so I'm actually going to not write the vocabulary out because the vocabulary is written right here for you, the definitions. If you would like to copy it, if you like to have all your notes completely filled out, you can just copy the definitions from down here right up into this space, okay? But a rhombus is a parallelogram. So think about what that means. First off, it has four sides. If it's a parallelogram, we know 5 things about parallelograms. So we know that opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. So everything we know about a parallelogram is true about a rhombus. Okay? And then a rhombus has its own little properties. All right. And the definition of a rhombus tells us that it's a parallelogram with 4 congruent sides. Okay. So all 4 sides are congruent to each other. A rectangle is a parallelogram. So again, those 5 facts, which I'm going to write down in a second, those 5 facts are true about a rectangle. And then a rectangle, by definition, is a parallelogram with 4 right angles. Okay. And then a square is a parallelogram. So all 5 facts about a parallelogram are true for a square. And then a square has 4 congruent sides and 4 right angles. Okay. So first thing I want to do is up here just a little bit, just review, okay, parallelogram. The 5 things that I just listed. So the 5 things are op, sides, parallel, op, sides, congruent, opposite, angles, congruent, consecutive angles are supplementary, and then diagonals bisect each other. All right, those 5 facts each other are true for a rhombus, for a rectangle, and for a square. Okay, so think of it as, and there is a flow chart I'm going to show you probably during class, and think of it as your parallelograms are up top, and then a rectangle and a rhombus come below, and all of the facts like trickle down to each of those. Okay, all right, so let me move down. So there is a corollary for our rhombuses. Okay. A quadrilateral is a rhombus if and only if it has 4 congruent sides. All right. So we already said that above. And then our corollary for a rectangle, a quadrilateral is a rectangle if and only it has 4 right angles. And then our corollary for a square, a quadrilateral is a square if and only if it is a rhombus and a rectangle. So think about that. Okay. If it's a rhombus, so if all 4 sides are congruent and it's a rectangle, all 4 angles are right angles, that makes it a square. All right. Okay. So then we have a theorem about our rhombus. It says that the diagonals of a rhombus are perpendicular. So we know that the diagonals bisect each other because remember, it's a parallelogram. Okay, so it is true that this piece is going to be congruent to that, and this piece is going to be congruent to that. But if it is a rhombus, then the right angles intersect to form a right, if it's a rhombus, the diagonals intersect to form a right angle, as you can see here. Okay, and that's what that theorem tells us. All right. And then erase that and go down. Here it says rhombus opposite angles theorem. A parallelogram is a rhombus if and only if its diagonals bisect a pair of opposite angles. Okay, so I know that in a parallelogram and in a rhombus that this angle, this whole angle is congruent to this one, and this whole angle is congruent to this one. But now I know that when the diagonal is drawn, it's cutting this angle in half. So I know that this little angle is congruent to this one, which is congruent to this one, which is congruent to this one. Okay, so for example, just to illustrate, if this entire angle was, let's say, 60 degrees, now I have 30 degrees, 30 degrees, 30 degrees, and 30 degrees. And it's same for angle D and B is being bisected as well by the diagonals. All right, so all four of these angles, 1, 2, 3, 4, are congruent, and all four of the other angles, 1, 2, 3, 4, are congruent as well in a rhombus. All right. And then we have a theorem about the rectangles diagonals. So in a parallelogram, the diagonals bisect each other, but in a rectangle, the diagonals happen to be congruent. So this entire length from A to C is equal to this entire length from D to B. So let's say that AC is equal to 16 and DB is also equal to 16. Well, then, since the diagonals do cut each other in half, each of the little pieces, 8, 8, 8, and 8, okay, because they're all congruent to each other. And I think that is it as far as the theorems are concerned. Okay, we are going to jump into some of the extra practice problems. Not all of them. I'm going to kind of skip around. Let's go down to problems 3, 4, and 5. Okay, so here it says the diagonals of rhombus ABCD intersect at E. So again, as soon as I know that it's a rhombus, I know that the diagonals intersect to form a right angle. I know that diagonals bisect each other. I know that all four sides are congruent. I think I'm up to 3 tick marks. So all 4 sides are congruent to each other. I know that the opposite angles are congruent, but the diagonals bisect the opposite angles. So if this angle's 44, this angle's also 44, this angle's 44, this angle's 44, this angle is going to be congruent to this one, this angle is going to be congruent to that one. So lots of facts to keep in mind. All right, now that everything's labeled, let's see if we can figure out the different measurements. We want to know the length of BC, this side here. Well, if all 4 sides are congruent, that means they're all 9 units long because that's how long the top piece is, AB. So BC is equal to 9. All right. What about AC? This segment here. Well, if AE is 7, how long is EC? EC is 7 as well. So the entire thing is 14. AC is equal to 14. Just add 7 plus 7. And the measurement of angle ADC. So I want to know the measurement of this entire angle right here. Well, if this angle is 44, I know that this angle has to be 44, right? So how big is this whole angle? It's 88. And what do I know about consecutive angles of parallelograms? They're supplementary. So I know that the measurement of angle ADC, the one I'm looking for, right, this one here, plus this entire angle, which is 88, has to equal 180. So subtract 88 from both sides, and you're left with 92 degrees. Okay. You could also figure it out because of the fact that we have diagonals that are perpendicular. This is a 90-degree angle. So if you want to just focus on this triangle, right? This angle's 90, this angle's 44. Add them together, subtract from 180 to find this angle, and then double it to get these 2 angles together, which is what we're looking for. Okay, so lots of different approaches here. It kind of depends on how you see the problem. All right, let's go down to numbers 6, 7, and 8. In exercises 6 through 8, it says the diagonals of the rectangle. So again, as soon as you read rectangle, everything about rectangles needs to be going through your head. All right, everything about a parallelogram is true, but I also know that I have 4 right angles. I know that the diagonals are congruent and bisect each other, which means all 4 little pieces are congruent. Okay. There are other markings I can make, but let's just see what we need to figure out. It says that you're given that angle HFG, which is already labeled as 31 degrees, and that the whole thing, H to F, this entire thing, oh no, it's not, sorry, E to G, sorry, E, where's E? E to G, this entire thing is 17 units long. All right, find the indicated measures. So the first one they want you to find is angle FHG. So going from F to H to G. So I'm looking for this angle right here. Okay. Well, if this angle is 31 degrees and the two angles right here have to add up to 90, right? We have a 90-degree angle. What's the missing angle measurement there? So you would do 90 minus 31, and you're going to get 59 degrees. So this angle is 59 degrees. Okay. So if I have parallel lines, because it is parallelogram cut by a transversal, aren't these alternate interior angles? So this angle is also 59 degrees. Okay, so I know that this angle is 59 degrees because they're alternate interior angles. You're given that EG is 17. That was given. So how long is FH? That's also 17 because the diagonals are congruent. Okay. And the last we want to know, what is the measurement of angle EFH, going from E to F to H? Well, we actually already figured that out. This angle is 59 degrees as well. Okay. Again, there's more than one approach to figuring out some of these answers. So if you saw something different in a different way, but you got the correct answer, I'm sure you did it correctly. Okay. All right. Let me see what else I wanted to jump to. I think that is actually going to be it. Let me just see real fast. Is this the page? No. Yeah, that was going to be it for today's lesson. Yep. So I will see you back here next lesson. Bye.